Let me show you one other place where a dictionary is an incredibly valuable thing to have. And to do that, I'm going to go back to a piece of code that we looked at a while ago. Fibonacci was counting the number of bunnies in a pen. Remember Fibonacci. It had two base cases. It said if n is equal to 1, the value is 1. If n is equal to 2, the value is 2. Otherwise, the nth Fibonacci number is the sum of the n minus first and n minus second Fibonacci number. It calls itself twice. It has to because it has to do that computation. And it will certainly work, but this code is actually very inefficient. And let me show you why. Think about what happens if I want to compute fib of, say, 5. To compute the fifth Fibonacci number, I need to compute the fourth Fibonacci number and the third one. But to compute the fourth Fibonacci number, I need to compute the third one, which needs to get the second one, which then also needs to get the first one. Now, those two are the base cases. I've unwrapped it all the way down to that level. Having got fib of 3, fib of 4 also needs fib of 2, and that's also a base case. And then finally, fib of 5 needs fib of 3 as well as fib of 4, and that's got to do another set of computations. It's building a tree of computations, if you like. Now, why do I say it's inefficient? I don't need to recompute those. I already know them. Well, in the case of fib of 1 and fib of 2, they're just constants, but fib of 3, I'm doing a computation there that I didn't really need to do because I already figured it out over here. And you can imagine if I was doing fib of 6, it would need fib of 5 and fib of 4. And down here, there would be a whole bunch of other structures that included things that I'd already computed. It's inefficient. And in fact, it really slows down when you start trying to compute large Fibonacci numbers. Here's where the dictionaries can really help us. Rather than recalculating the same value many times, let's just keep track of what I've already done. So here's a nice version of fib that's very efficient. And it basically says, I'm going to compute Fibonacci, the nth Fibonacci number, but I'm going to give it a dictionary. And what I'm going to do is say, if I'm computing this Fibonacci number for the first time, I'll do the work as I normally would, and then I'm going to store it into the dictionary. But if I've already done the work, just look it up and return it. So if n is already in the dictionary, I just look up the value and return it. Otherwise, I do the recursive call, as I would have done before, compute it. Having done that, I store that value away in the dictionary, and I return the answer. And I'm saving the answer here because I need to hold on to it in order to be able to return it. To start this up, I need to give the base cases in the dictionary. So there I go. I put into the dictionary the first and second Fibonacci numbers. And then I can just go ahead and do the work. This process is sometimes called memoization. It's a way of creating a memo to yourself that remembers what you've already done. And that turns out to be much more efficient. So let's look at a couple of examples of this. And so over here, I've got versions of fib and fib efficient. I'm going to initialize the dictionary. And I'm going to just set up an argument. Say I'm going to compute let's start with something simple. Let's just compute the fifth Fibonacci number. And I've set up a little print routine that's going to print them out so you can see how well it does this. And if I call this, oh, it did it really quickly. And it gives the same answer, which is good. Now, let's give it a little bit bigger number. And I want to let you watch how long it takes to do the computation, because I'm going to do the straightforward one and then the efficient one. There was a little bit of a gap there, but it was almost the same. Now, let's give it an even bigger number, which is 30. Oh, and you notice the pause. And in fact, if I do one more, I don't want to make it too long, but let's make it 34. And I do this. It's working on fib. It's working. Oh, and fib efficient came about really quickly. So what that's doing is saying I can use the dictionary to hold on to values that I've already computed that I don't need to recompute. And it gives me a really efficient way of doing this computation.